Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 17b, Circles, Polygon. Math, Exercise 17b, Circles, Polygons. In this diagram, AD is the diameter, O is the center. Chords AB, BC and CD are equal. If angle DEF is 110 degree, how much is angle AEF? So for that, I'll have to draw AE, join AE. So this is the angle asked. First of all, angle AED will be 90 degrees because AD is a diameter, so angle in a semicircle is always 90 degrees. So the total angle is 110, out of which this is 90. So this angle, angle FEA, will be 110 minus 90, which comes out to be 20 degrees. Next, they want angle FAB. FAB is this entire angle. There's no way we can find it at one go, so we'll break it up. First of all, angle FAD can be found out using the cyclic quadrilateral property. You see, AFED is a cyclic quadrilateral and angle E is entirely 110 and opposite angles are supplementary. So this would be 180 minus 110, that is 70 degrees. Now I need to find out this angle so that I can add it and get the total angle which is asked. But how do I find this one? They have mentioned that chords AB, BC and CD are equal. Now there is a property that equal chords subtend equal angles at the center, which means that if the chords are equal, then their respective central angles are also equal. So let this be equal to this, be equal to this, that is x, x and x. But these three angles are on a straight line. So totally it should be 180. So each x will be how much? 60 degrees. That's right. You could have done it without x also. Directly you could have just mentioned this is equal to this is equal to this, and that is 1/3 of 180, 60. Now in triangle OBA, we know that OB and OA are radii. That means this angle will be equal to this angle. Isosceles triangle property, let them be equal to x or y or whatever. So angle sum property is totally 180. So how much will this be? 60. So now what's the total? 130 degrees. Here's the solution. Cancel questions 1 and 3. They are very easy, but you may do it for extra practice. By the way, 1 and 3 are proving sums, so it is not there in the reduced syllabus. Now the fifth sum. In this diagram, there is no diameter given. What is given, however, is that AB is a side of a regular 6-sided polygon, that is a hexagon. Now, the property of this is that the central angle can be found out using the formula 360 upon n, where n is the number of sides of a polygon. That means if I want to find AOB, this will be 360 upon 6. On the other hand, they have mentioned AC is a side of a regular 8-sided polygon. That means that this is a side of an imaginary octagon. Of course, there would be 8 sides which they have not shown. They have shown only one side. But that's useful because if I draw its central angle, I can find it. it will be 360 upon n, and here n is 8. So that will come to 45 degrees, which will help us to find the other angles. So first, join OC, find AOB, which will be 60 degrees, find AOC, which will be 45 degrees. They also want us to find ACB. Any guesses? How will we get this? Well, isn't ACB half of AOB? Because circumference angle is half of the central angle. So that's 30. They also want us to find ABC, which is half of AOC. So 45 upon 2, 22.5 degrees. So they've never asked us to find AOC. But without finding that, we couldn't find ABC. Here are the steps. Next, let's do the seventh sum. So this side is equal to this side is equal to this side. That's going to be useful. First, let's find AEB. Okay, it is not necessarily going to pass through O, so I'm going to avoid that. How do I find this? You might be thinking that if the chords are equal, then the central angles are equal. That's true, but there's a shorter method to solve this sum. Let me join CE as well. Now there is another property which says if the chords are equal, then the angles subtended at the circle are also equal. That's a theorem. So if AB is equal to BC is equal to CD, then angle AEB is equal to angle BEC is equal to angle CED. Now, look at cyclic quadrilateral ABCE. If this is 132, then this will be supplementary to that, opposite angles of a cyclic quadrilateral. So how much would that be? 48 degrees. And we just proved that this angle is equal to this angle. So each will be 24 degrees. In fact, even this will be 24 degrees, because since the chords are equal, the angles at the circumference will also be equal. That's a property. So first they want us to find AEB. Done. 24. Next they want AED. So first we will find CED, which is also 24, and then add all of them. That's 72 degrees. That's the answer for AED. Next they want COD. Well, this seems to be a central angle of something. So it's a central angle for angle CED. So it will be double of CED. So that becomes 48 degrees. So write the steps. And finally the 10th sum. Here again they've mentioned that BD is the side of a regular hexagon. So if I assume O to be the center of the circle and I join BO, and because they mentioned AD is a diameter, that was very important, because we can never assume that it is a diameter, but we can assume the center if a diameter is given. So BOD will be 60 degrees. I just showed you that the central angle for a regular polygon is 360 upon n, and here n is 6, so 60 degrees. Similarly, they have mentioned that DC is the side of a regular pentagon, so 360 upon 5, how much is that? How much? 72 degrees, correct. So I got two angles. With the help of this information, I can find the rest. So let's start. Let me write the values here. 60, 72. Angle ADC is asked, this angle. Well, triangle ODC is isosceles because OD and OC are radii. That means this angle will be equal to this angle will be equal to X, and they are totally 180 degrees, 1, 2, 3, angle sum property. So that's how I get the value of x as 54 degrees. Next we want angle BDA, that is this angle. So the same method applies in the triangle OBD. OB and OD are radii, so it's an isosceles triangle. So this angle is equal to this angle is equal to y. Angle sum property, this comes out to be 60 degrees. Angle ABC. Angle ABC, this whole angle. How will we find that? Do we have any central angle for that? Yeah, angle AOC is a central angle for that. So angle ABC will be half of angle AOC. But how do I get AOC? Well, AOC is supplementary with COD because it's a linear pair, angles on a straight line, linear pair. So if this is 72, this is 108. If this is 108, this is half of that, 54 degrees, done. And finally, angle AEC. AEC. Well, in cyclic quadrilateral AECB, angle E and angle B are supplementary, opposite angles. So if this is 54, this will be 126 degrees. Done. Here are the steps. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.